Okay, let us start with the last problem, the fifth problem for this week. An investigation to measure the acceleration of free fall, a rod is suspended horizontally by two vertical strings of equal length. Okay, a rod is suspended here, the strings are jettisoned T apart. Something what is called as a torsional pendulum. And when the rod is displaced by a small angle and then released, simple harmonic oscillations takes place horizontally. What you do is take this one and you displace it by a small angle, which means what? You are rotating this with respect to this axis. The rod now becomes something like this. Rod becomes something like this. Okay, so this is how the rod now becomes. Adjusted by a small angle. Adjust the rod over here, the rod over here. So you twist it like this, just like this. So it starts oscillating like this. This is what you have done. Okay. Simple harmonic motion takes place in a horizontal plane. The theoretical prediction for the oscillation is given by T equal to C by D root G. C is the numerical constant. State the unit of C. So you need to get the value of C. So simple one, the C unit you want. So therefore what you do is take this as subject. C is equal to T to D to root G. So what is the unit of T? What is T here? Time period of oscillation. Time is measured in seconds. And D, how is D measured? D is a distance between the two strings, which is measured in meter. What is G? G is equal to meter per second square, right? So it should be square root of meter per second square. What is this? Your acceleration due to gravity. So it should be second meter into meter power half into second to the power of minus half whole square. Sorry, whole half. Second to the power of second square whole to the power of minus half. This just goes away. So I get second meter to the power of 3 by 2. I have added 1 plus 1 by 2, which is 3 by 2. And then you have a second power minus 1. This and this goes away. Get the answer as meter power 3 by 2. So your final answer. Okay, now let us move on to the next one. A student records the time for 20 oscillations of the rod. Explain how this procedure leads to a more precise measurement of time for the one oscillation. How do you get a precise measurement? First one is when you record something for 20 and then you try to find out the time taken for one oscillation. That means what? So your uncertainty measuring time taken for one oscillation reduces by 20, right? It reduces by 20. That is what exactly happens. Secondly, it is like, say for example, I have this one here. First time I measure. If I want to find out what is the time period of oscillation, first time I measure here. Okay, I find out what is the time taken. Now, if I do it only for one oscillation, I am doing only one time. But on the other hand, if I do it for 20 oscillations, what can happen? Okay, sometimes I may get different answer, but I will be able to average it out, or in other words, the random error has been minimized. You can say more the number of oscillations, random error is minimized. Why is it minimized? The reason is because the more the time it takes over here, it will automatically. So sometimes when you start from here, what can happen? It can now wobble around like this over here. It can move in 2 planes, 3 planes like this over here. But when you let it done for a longer time, then automatically it will stabilize itself. It's always better to do it for 20 oscillations. Okay. Now these are the two reasons why we say we need to do more number of oscillations. Do not restrict yourself to 5 or 6 oscillations. Then, in one experiment, D was varied. The graph shows the plotted values of T versus 1 by D, and the error bars are negligibly small. See, whenever you have a graph problem, first thing that you should have is you should have in mind how was the variation happening. Just go back to this. See what is the variation given by T is equal to C by D root G. Write down this equation. It will be very helpful for us. T is equal to C by D root G. What is given? This is plotted against 1 by D. Now let us write down the variable function here. See, T is plotted along the y-axis, which should now be equal to X is plotted along 1 by D. X is nothing but 1 by D. Then write C by root G divided by D. Okay, or I'll write C divided by root G and write proper. C by root G into 1 by D, which is equal to M times X. X is nothing but 1 by D and M is nothing but C by root G. Okay, right? M is equal to C by root G. That means if I find the slope, I will be getting the answer C by root G. Okay. Now this is what has been given. Now draw the line of best fit for these data. Now, why did I do all these things? The reason is because when I am drawing the line of best fit, I need some idea about it. Okay? Whether it is going to be a linear curve or whether it is going to be something like a curved line, what is it, and so on. So therefore, now I see this is now equal to an equation is y equal to mx, which means what? This is now passing through its origin, right? So when I draw a straight line, starting from here, it should pass through the origin. First is, let me connect all the dots. When if you're doing in the exam, you better have a scale, then do it. And lastly, what you do is you need to pull this one back so that it touches the arc. Okay, it should not have an y-intercept or an x-intercept. It should have y and x-intercept be 0, 1, 3, because you had an equation y equal to mx. But on the other hand, if you had y equal to mx plus c, then definitely it will have a y-intercept. Okay, so this is something from the geometry you need to know. Now, draw the line of best fit. We have done it now. Suggest whether the data is consistent with the theoretical prediction. Yes, it's for 2 marks. Now, can you stop with just an S? You cannot stop with an just a moment. Okay, so you cannot stop with an S. Now you have to say whether first is since t is equal to d, what was it from here? Here c by d root g. T is equal to c by d root g is equal to c by root g into 1 by d. Okay, so since there is so much, so the line should pass to the origin. That is seen in the graph. That's the first thing that you have. And secondly, the line, the plot is a straight line hitting the slope to be a constant, which is equal to c by root g. And this also seen in the graph. Both things are seen, right? So therefore, data is consistent with theoretical prediction. Okay, let me move on to the next. Oh, that's it. We have come to the end to this, and one more question somewhere. I missed it. Okay, that's it. So the last one. Okay. So with this, I think we have come to an end to the last question. So let me see you in the next week by 5 more questions. Thank you. Thank you very much.